first up, Mike's been doing some great work here, making a 3.4 gigs receiver, I believe. So this is a joint presentation with Mike, G4CDF, and I have provided the signal sources and the receiver. So the signal source is a HackRF1 USB device. Like that. They're about 250 quid-ish off Amazon, and will receive and transmit, not at the same time, anywhere between about 1 megahertz and 6 gigahertz, I believe. It probably won't be terribly clean, and I think Mike and I have observed that. But it's a handy piece of kit. The best way to think of one of these devices is a bit like a USB sound card. So you send or receive your modulated data to the device, and it will transmit it for you, or it will receive. Yeah. So I'm doing providing the signal source, and also on receive a receiver, which is an AirSpy USB dongle.
Thanks, John. First of all, I'm going to describe what I'm doing here, which is not at 3.4 gigahertz. It's at 1296. This is showing my interdigital filter. It's a 4-line interdigital filter that I tried to make. It's the second attempt. The first was made in an aluminium die-cast box, and it was pretty useless. This one actually does filter. You might be able to see it's tuned to 1296, but it's a bit skewed, and it's not a very good implementation. I think the design is okay, but the implementation's not so good. So the next stage is to try and improve on that. The aim of this was to put it in the and between the antenna and the preamp to kill any other cellular radio interference and so on. I brought along as well, which we can show later, a tunable filter which came into my possession at Michael Raleigh a few years ago, and it tunes from 1350 to 1850 megahertz. And in the pack, 2 of these filters arrived with the circulator, and I've managed to retune the bottom end of this one to cover 1296 as well, just by adding bits of solder to the tuning capacitor inside. The interesting thing about that is it's made by Forum in Italy, and it was a company we contracted out from Rakel to make some filters for us, and they found them the way all the way back to the radio amateur market. So I picked up 2 of those for £4. Anyway, that's 1296. More interesting, 3.4 gigahertz. I think this is the first time I've seen anybody put together any 3.4 gigahertz equipment. It all started by a friend of mine who worked for Cullen, acquiring a lot of power amplifiers that covered 3.7 to 4.2 gigahertz. And also will cover 3.4 gigahertz and give 20 watts out for 10 milliwatts in, and you can still buy those. In fact, there will be some on sale at the rally, this coming rally. Certainly parts of them as well, but you can buy the full things. They're massive and they're really only suitable for home station use. But that started the interest in 3.4 gigahertz. So then at a rally up in the north, I picked up an oscillator block, microwave oscillator block, and an ionica down converter. The oscillator block, once you've worked out how to tune it, it is relatively simple. It's a bit awkward in that it needs minus 22 volts supply at a lot of current, like about half an amp, and hence the heat sinks. They're not there for any other reasons to get rid of 10 watts of power. The Ionica receiver module is plus or minus 12 volts supply, but it takes in 3.4 quite nicely. But unfortunately, this selected something like 900 megahertz as the IF, and it was pretty useless for anything. So you have to take that out and bypass it. So I wrecked the filter getting it out, but I got it out yesterday, and it's now feeding. This is taking 3.4 into the receiver, coming in this stage from the HackRF, mixing with 3.860 gigahertz to give 460 megahertz out. And John's doing the clever bit. You'll be able to hear what's going on there. And finally, the only other thing I'm going to say is I made this little module, which is basically an oscillator. It's an oscillator. It's a mini circuits oscillator that you can tune anywhere in the 3 to 4 gigahertz range, and I use that for testing all of this. Anyway, I'm going to pass it now on to John to cover the clever bit.
Yeah, that's, to be honest, I've really covered it. The HackRF is just doing the signal generation there, and I've got an ASPI doing the receive. So if you want to ask any more details afterwards, I'll quite happily take you through it. But I think at this point we'll move on. So it's who's up next? Is it Tom?
Is it room for any questions?
Yeah, I can take questions. Yes.
Is that GNU radio you've got there on the laptop? Is that GNU radio?
That is GNU radio. Yes.
It's GNU
Yes,
radio.
it is. Yes. So yeah, I can tell you all about that if you're interested. But as you can probably see, it's block based, so you get to define your signal processing chain in software. And it's very, very simple. I've just got a constant source, and that's keyed on off every every second or so at the moment, just for a demo. But you could get it to do any modulation you wished. I'm working on a project to do DAB perhaps, or yeah, you could possibly do digital modes as well, sort of DMR perhaps. And certainly do things like DMR receive. Any mode you wish to demodulate or modulate. There you go. Sorry.
Yes, I'm lagging well behind Mike and yourself on 23 centimetres at the moment.
So getting together to try to do things on these higher band frequencies. Like John and I have actually made a contact between us just over a kilometre on 23.7's SSB, which is a magic start. And this is a second stage of getting things working on 3.4 gigs. And we're hoping to do the same, have a contact on 3.4 of that same distance.
Thank you.
Yeah, that's fair.
But we licensed on 3.4 gigs.
3.4 to 3.41. It's
So now
on 3.41 gigahertz. So it's a 10 megahertz bandwidth.